Hello friend, welcome. My name is Derek Carter, and in this video we're going to be continuing to talk about application program development. So this is the first video where we're going to actually start talking about the Python programming language. So in particular, we're moving on to chapter 2 in this video. We're going to look at the first few seconds of chapter 2. We're basically going to start off looking at getting input from Python using the input statement and printing out results, so using the print statement, and then also a little bit about doing some processing, some statements and things. Okay, so before I get into some more details about input and output in Python, just one or two more kind of high-level concepts. So typically when you're creating a application program, you'll go through these kinds of this development cycle to create a program. So the most important is probably design, the design stage. Okay, this course really isn't about design. That's more of an advanced. If you become a software developer or a software engineer, you tend to spend most of your time actually in analysis and design and gathering requirements and stuff like that. So in this course, we're going to usually kind of start at the idea of writing the code. I mean, you have to put a little bit of thought into the algorithm, the steps you need to solve like a question for an assignment, right? So in this course, we're going to use the Python language to write a program. So the next step when you have a program written is syntax error. So remember in the previous video, we talked about the Python interpreter takes a statement, but in order to take a statement and translate it to machine language, the statement has to have the correct syntax. And if it doesn't have the correct syntax, Python can't translate it into machine language instructions. Okay, so these are the easiest kinds of errors because Python tells you your program, I can't run it, right? It has errors, and so you first, when you write a program, have to correct any syntax errors. But once it's running, there can still be other kinds of errors. So these are logic errors, right? And this is where debugging. So, and these can become quite complex sometimes to figure out when you have a logic error. So your program's running, but it's not getting the correct result, right? And that's where debugging and testing come in, right? So yeah, just to summarize a little bit of what I just said. So design is the most important part of program development. And design is really about understanding the task the program has to perform. So you get a little bit of that when you do the assignments for this class, but you're really going to be creating an algorithm. So from the assignment description, you have to come up with the set, determine the steps that must be taken to solve a problem. And we'll teach a little bit about how to do this, how to break a big problem down into smaller steps so you can solve it as a sequence or series of steps, and then create that algorithm to solve the question or the problem you're asked to do. So some of the tools that you might see in this textbook are pseudocode and flowcharts that we might use in the textbook and in our class. I want to talk a lot about these. Pseudocode is really not real code, but it's fake code, as the name implies. So the difference is being that it doesn't have a formal syntax, so there's no language that can translate pseudocode and actually run it, right? But it can be useful to first write stuff out in pseudocode before you get it into a real working high-level language, right? Also, flowcharts are similar to pseudocode, although it's a little bit more formalized. Some of the stuff that's missing from here is you need to have ways to show, like to make a decision. So if this is true, do something. If it's not true, do something else. Or to do some statements repeatedly, okay? But that's on purpose. So later on in the next chapters, we'll talk about how you do those kinds of things in Python or in a programming language. Okay, but in this video, for the rest of this video, we're going to be concentrating on getting input using the Python language and producing output, so showing results, okay? So typically an application, when you write an application program, it performs a three-step process. Get some input, so some data from the user or somehow, like maybe from a file or a database, performs some calculations on it, so it processes the input. So, typically like mathematical calculations we use a lot of as examples of processing or text manipulation, and then we produce an output. Okay. Okay, so the first thing we'll talk about is displaying output with the print function. So you've already seen some examples of this if you've been watching the videos or reading our textbook. But a few more details about this print thing that you've probably seen a couple of times now already. So the print statement we've been using is an example of a function. Okay, so we'll talk a lot about functions in this class. So a function is a piece of pre-written reusable code, right? So you don't have to write the implementation for print, but you can use it, right? So and the basic use of print is to display output on the standard output terminal. All right. So print, if you didn't realize it, it takes arguments. You've probably maybe only seen it with one argument so far, but you can actually give it multiple arguments. So an argument is really just a piece of input. So you can pass in literals, like string literals like we have here, or variables as arguments to functions. And when you pass in an argument to the print function, it will take that, interpret the argument, and display it on the terminal output. So print basically needs string arguments to be passed into it. So you can give string variables or string literals to the print statement in order to print out output. Okay, so there's a couple of different. There's three basic ways that you can create specify a string literal in Python. So and make sure you understand what we mean by literal. So that just means it's an actual set of characters rather than a string that we save in a variable that we'll show in a bit here, right? So you can use single quotes, double quotes, or you can use these three quotes in order to create a string literal that goes over multiple lines. Okay, I'm going to jump over and show some examples of these, but yeah, let me show quickly a few examples of all three of these. So I'm going to use VS Code, but basically just using Python in interactive mode just to demonstrate stuff here and in this video mostly. So just for all three of those examples that we looked at, so we can print out by passing a string literal like this, so in between single quotes. All right. So we're in this class prefer single quotes. You should use double quotes usually for most assignments. If you need to put like a single apostrophe on there, so something like that. Oops, these do need to match, right? So if I'm using double quotes for the string literal, it has to start in with double quotes. But so if I'm using double quotes, I can freely use single quotes in there, and vice versa. If I need to use like a double quote inside of a string literal, I could use single quotes and put the double quote there. But most Python style preferences say, stick to single quotes for string literals unless there's reasons not to. And there's a special one that you'll see a lot. I'm going to show it like I did in my slide. I'm going to create a variable. We'll come back and talk about variables here. But if you use three quotes, you can actually have a string literal go over multiple lines. So what that means is that the characters, but also the invisible characters like new lines and things, are part of the string literal. And I say I mistyped that. I'm going to start that again. So I meant to call the variable contact. So I can put all of this text on multiple lines in my string literal. So yeah, I probably wouldn't normally do this interactively. I mean, just put this in a file and run this, use a Python script instead of doing it interactively. But here I've defined, this is another type of string literal. It's just over multiple lines. Okay? So you see, I mean, all that text is in the variable because of this string literal that starts with three double quotes and ends with three double quotes. So three single quotes doesn't work. That's not a valid syntax, part of the Python syntax. So it's either single quote, double quote, or the three quotes to do a literal over multiple lines. Another topic here, let's just mention comments real quickly. So all high-level programming languages support the ability to comment your code. Comments are not used by the programming language, so they're ignored by the Python interpreter. These are really for communicating with other humans, okay? And I know, for people that are just starting to learn programming and software development, it seems that the purpose of comments is sometimes a little bit, not clear. But really, writing software, doing software development writing any program of any complexity, the real problem, the real time is going to be spent in maintaining the code and communicating with group members on a team, a large team that's doing software development, what this code does, how it works, right? So comments are very important, especially in the medium and long term, in order to communicate the intent of a piece of code to your future self, to other people on your team, things like that, okay? So I'm going to switch to, let's create a file here. I'll create a file, call it comment.py. So if you want to have a comment, just use the £sign. Right. So here I might have used a comment in order to have my string literal that we were just doing before. Right. And since I created that file, we can run it interactively. So normally comments, again, it's the book also mentions end of line comments. Most Python styles and don't recommend using end of line, so line comments that go at the end here. So they have their uses. They're not forbidden, but end of line comments tend to either result in short comments, too brief, that aren't helpful, or if you have long lines, your end of line comments end up making your lines too long. So usually you should prefer just whole line comments above the code that you're writing in this class. And I do ask, you might get code reviews from me or the TAs about, you need to comment your code here, be clearer by adding a comment, things like that. So another concept here, the idea of variables. So variables are very important, and we've already kind of run across these. I've used variables without really explaining them a couple of times in previous videos, and even just before a little bit, okay? So a variable in a high-level language like Python is just a name that represents a value stored somewhere in computer memory, okay? So in Python, it's really a reference to some address in memory that we hold a value in. Okay, so we create a variable in Python by assigning some value. So usually a literal value, although you can also execute some expression and assign the result into a variable. So switching back over to what I was just typing here. Basically, this was an assignment statement, and this was a literal. So this was an example of the second thing I was talking about, where we assign a literal value into a variable. We can also assign an expression like this. So here we would end up executing some expression, and the result of that, 7 in this case, will be assigned into the variable here. So we can print out both of these if we want to. If I say that if you're running a program, a script using the Python interpreter, make certain that you save your file before you run it, or else you won't see the stuff you typed in there. So if I rerun it, I get the same thing I had before. I switched away, but also I created another variable called sum, which has 3 plus 4 in there. So and we print out the result of executing that expression. Okay, so just a few more comments about variables. In an assignment, the variable that you're setting must be on the left-hand side. You can have variables on the right-hand side. You can also use variables and pass those in as arguments to functions. So we'll see examples of that in a bit here. But yeah, variable names should not be enclosed in quote marks, right? So a quote mark is used for a literal string, not a variable. And you can only reference or use a variable in an expression or pass this argument if a value has been assigned to it. Okay, so jumping back real quick to that last one is kind of important. Here I've defined a variable called sum and I assigned it a value. But if I reference something that I haven't assigned anything to, that's an error. So we'll get an error that it's not defined if you try and use a variable that hasn't actually been assigned a value yet. Okay, so I'll just mention the rules for naming variables in Python. This is common for lots of high-level programming languages. Look at the textbook for more details about this, but basically, you can't use a keyword. So keywords are reserved for something else. So you can't use something like if or try as a variable name, because those are keywords in Python. Variables can't contain spaces, so the syntax, the way that the interpreter determines if something is a variable in a statement is it needs to have white space before and after. So you can't have a white space as part of the name of a variable. Basically, you can only use characters, so upper and lowercase letters, or numbers, or underscores in variable names, but the very first character can't be a letter or an underscore. Sorry, the other way around. The very first character can't be a number. So the first character has to be a letter or an underscore for a variable name. All right. So I'll just jump to our textbook real quickly. Here's some examples of legal and illegal ones. So these make good quiz questions. As long as it starts with a letter or an underscore, there weren't any examples of starting with an underscore. But it's illegal to start with a number, right? So here is illegal because of 3. Here, other punctuation besides underscore is not allowed. So the pound sign can't be used in a variable name. And the last thing before I move away from here, variable names should reflect its use. So variable names should be meaningful. So you might get that from me a lot as code review comments. So as you're doing your assignments, you might want to look through the links that I have about giving good names to your variables and your functions and things. So this is part of becoming a good software developer is being able to write readable code, right? And the first step in readable code is giving meaningful names to variables and other stuff, functions and classes and things in your code. Okay, so one thing about functions, like the print function, is they can often take more than one argument, okay? So the print function is no exception to that. So you can actually pass in multiple arguments to the print function. And as we show in the example code on the slide here, you can pass in you can give literals, or you can pass in variables as the arguments to the print function. So in this case, if the variable has this value in there, we're passing in 2 arguments to our print function here, and it will print those out. It will basically put these together. The first argument will come out first on the output, second argument, and you put as many arguments to print, as many items as you want to the print statement. And as a final thing, I want to mention about data types of variables. Okay, so Python, unlike some other high-level languages, you don't have to specify what the data type is when you create a variable. It infers the data type for you. But every variable you use in Python, or pretty much in any programming language, there is a data type associated with it. All right. So at the beginning of this class, and for the majority of this class, you'll mostly be using 3 different basic data types. So those are ints, floats, and string data types. Okay. So in my small examples, we've already seen some examples of all of ints and strings, I think. But let's be explicit about some of these. So here I'm assigning a variable called s. That's not a good name for a variable. It's too generic, but and we're assigning it a string literal. And like I was saying, prefer using single quotes for string literals. So it infers, since this was a string literal, that we should use a string data type, right? So type is another example of a built-in function that you can use in Python. This will tell you what type is currently assigned inside of the variable. If you use a numeric integer literal like this, right, a whole number, Python will use an int, right? And integers can actually hold signed integers, so positive or negative values. Here's an example of reassigning the values. If I wanted x to be -5 instead of +5, I could assign it the int literal, the numeric literal -5 will still be interpreted as an integer. Right? And then finally, we'll do a lot of stuff with floating point numbers or real valued numbers. So here, anything that has a decimal point in it, a period in it, will be interpreted as a real valued number. So if we look at the type, it gets assigned a basic data type of a float. Okay? So there are other built-in types, but a lot of the stuff we do in this class for the basic data types will be either integers, floating point types, or string types. Okay, so that's basically it for this video, the first part of chapter 2. Just to summarize some of the stuff that we covered in this video, typically applications that you build perform 3-step process, and they actually do this repeatedly, which I may not have mentioned. Right, so we get some input, we process it, and then give the output results. Then we might keep doing that for some new input. Right. So we only really talked about output and kind of variables in this video. So the basic way to get output to the terminal, standard output, can be done with the print function that's a part of the Python-based language. So, we'll talk a lot more about functions in this class, but functions are basically pre-written reusable code, although you can also write your own functions, as we'll later find out, that have input arguments and can return a result. Okay, print doesn't actually return a result. It, as a side effect, whatever you ask it to print, whatever arguments it give, end up being shown on standard output, whatever the standard output currently is. Okay. Specify string literals using single or double quotes, or I should add on the 3 quotes if you need a string literal that's a multi-line string literal. Do use comments, okay? So comment your code keep in mind the human readers of your code that are going to be reviewing and giving you evaluations for your code and giving you grades for your code. You can clear things up by adding comments to your code. And then variables are an important part of any programming language. You have to know how to use them and specify them. In Python, we can reassign variables and assign variables to them. Python infers the basic type of a variable from what you assign into it initially. Okay? Variables can be used to pass in as arguments to functions. And I already mentioned variables have a type that's determined when they're assigned. And we'll be using a lot of the things we do will either be strings, ints, or floats in this class. All right, so that's it for this video. I hope these things are useful for you. As usual, hit me up, hit the TAs up if you have questions, send us emails, and I hope you keep watching the videos, and I hope to see you in class.